In this video, I am going to discuss about electron beam welding process, EBW process. In electron beam welding process, the heat required for welding is obtained from kinetic energy of very fast moving electrons. When very fast moving electrons strike over the workpiece surface, the kinetic energy of electrons are transferred into heat energy. That heat energy is used for melting the base metal to be jointed. Electron beam welding processes are commonly used for welding costly metals such as titanium, molybdenum and tungsten as structural components. See, electron beam welding process is completely a automatic welding process performed in a vacuum without a shielding gas. So electron beam welding process that are commonly performed in a vacuum. The reason is, if it is not performed in a vacuum, there is a chance that very fast moving electrons collide with air molecules and the energy of the electrons will be get reduced. The vacuum pressure commonly using the chamber is 10 raised to minus 3 to 10 raised to minus 6 hectopascal. That's very important. 10 raised to minus 3 to 10 raised to minus 3 to 10 raised to minus 6 hectopascal vacuum pressure is used inside the vacuum chamber while the electron beam welding process is taking place. See, in an electron beam welding process, there is no electrode or filler rod is used. See, the electrons are emitted from a filament, heated filament that is known as cathode. Commonly using tungsten filaments are commonly using, which is used for emitting the electrons, that is cathode. These emitted electrons are focused as a beam and directed to the weld point. When these electrons hit the base metal, the kinetic energy of the electrons are transferred into heat energy. That heat energy is used for melting the base metal to be jointed. See, the approximate speed of electrons during electron beam welding processes range from 48,000 km per second to 192,000 km per second. So these very high speed electrons hitting the base metal, the kinetic energy of the electrons are converted into heat energy. That heat is used for melting the base metal to be jointed. See, this is the electron beam equipment, electron beam welding setup. See, electron beam welding machine consists an electron beam gun, then a vacuum chamber, a transport system. So we have already discussed what is the importance of vacuum chamber. If the vacuum chamber is not provided, if vacuum is not provided in electron beam welding process, there is a chance that the very fast moving electrons collide with the air molecules and the kinetic energy of the electrons will be reduced. See, electron beam welding process consists an electron beam gun. See, this electron beam gun consists tungsten filament, anode, cathode and focusing coil. See, this is the electron beam gun which consists tungsten filament, cathode, anode and focusing coil. Okay, see, the entire equipment is in a vacuum chamber, inside the vacuum chamber, which consists of a vacuum pressure of 10 raised to minus 3 to 10 raised to minus 6 hectopascal. See, this filament, tungsten filament, when heated to 2000 degrees Celsius, when the tungsten filament is heated to 2000 degrees Celsius, it will emit electrons. And these electrons are passing through the cathode. Cathode is negatively charged. When these electrons are passing through the cathode, the electrons are repelled from the cathode. Repelled from the cathode and it become a narrow beam. It become a narrow beam. And this electron beam is passing through the hole in the anode. Anode is positively charged. And the electrons in the electron beam become energized when it is passing through anode due to the potential difference between the cathode and anode. So due to the potential difference between cathode and anode, the electrons passing through the cathode will become energized and it will pass through magnetic lens which focus the electron beam in the weld point, and there will be a deflecting coil. What's the purpose of the deflecting coil is which is used to focus the electron beam correctly in a position. When this very fast moving electrons in the electron beam hitting the workpiece or strike the base metal, the kinetic energy of the electrons is converted into heat energy. That heat energy is used for melting the base metal to be joined. So this is the principal working of a electron beam welding process. So what's the advantages of electron beam welding process? The weld zone and HAZ are relatively small. HAZ means heat affected zone are relatively small. See, in electron beam welding process taken place by the narrow beam of electrons. So the weld zone and HAZ are relatively small. Distortion effect is only very small. On steel plate, 100 mm thick welds can be made in one pass at a speed of 170 mm per minute with penetration. Speed of welding is high, no porosity and contamination. So these are the advantages of electron beam welding process. And the disadvantages are cost of equipment is high. Obstructed joints can't be welded because electron beam travel in a straight line. Job is limited in size as per the work chamber dimensions. So these are the disadvantages. Cost is very high. Obstructed joint cannot be produced. Job size is limited. And applications. See, electron beam welding are commonly used for welding very costly material like titanium, molybdenum and tungsten. This is the main application of electron beam welding process. So in this video, I have discussed about electron beam welding process, what are the components in electron beam welding equipment, and the advantage, disadvantage and applications. Thank you.